Good day, everyone. We are here to present our thesis study entitled Assistive Technology for Braille Reading Using Optical Braille Recognition and Text-to-Speech. My name is Justin Troy Mateo.
And my name is Derek Roque.
So, for our introduction, for Braille reading, it's a process performed by the unsighted people to decode a tactile writing system with paper embossed of dots. It is traditionally the means of communication for the unsighted since it became an effective and proven to enhance their literacy. So here we have an example of Braille symbol. So we have printed multiple pages of Braille documents, and here we have one of the examples. Here is the example that's been zoomed in. Okay. So for our statement of the problem, so often people with normal vision neglect the literature of the visually impaired because unfamiliarity. So basically, when sighted people tend to disregard the Braille documents because they don't need it because they can see regular text. So also manually reading Braille takes time and skill and is usually prone to human error due to fatigue and other factors. So the main objective of our study is to envision building and designing a Braille to speech system bridging the literature of the visually impaired and people with normal vision. It aims to assist users in reading standard size unconstructed Braille documents. So the specific objectives of our study are the following. First of all is to construct a system that would translate the Braille document to English speech using Raspberry Pi 3 microcontroller. Second is to implement a Python code with image acquisition and processing techniques to acquire the necessary data. Next is to integrate the text-to-speech technology that will allow us to translate the data into speech. And lastly, to verify the accuracy of the system by subjecting it to our statistical treatments. So for our methodology,
I'll be discussing the hardware block diagram. Our hardware make use of a Raspberry Pi microcomputer to process image processing and data transfers within the system. To be able to power it, we used a 12 volts power supply and a DC jack adapter to be connected in a step-down converter. This step-down converter is a 5 volts step-down converter which enables us to power the Raspberry Pi. From the DC jack adapter, it is connected to a white LED strips that will serve as the lighting inside our system. Then, we have connected also a camera in our Raspberry Pi to be able to capture an image of Braille image from a Braille document that we can insert in the system. Then we have attached a push button to initialize, so we can press that push button when we need to initialize the system. Then lastly, the speaker, which gives us the output of our system. Here is a picture of our system. Inside, there's a speaker, the Raspberry Pi, and the white LED strips. So, as I said, there are two white LED strips, but they are just connected in series. So, once the system is connected to a current, it will just turn on. Here is our complete prototype. So, inside it is enclosed using an acrylic sheets. It's actually an clear acrylic sheets, but we haven't removed the sticker so that it can prohibit light from entering in the system. That it can capture because of the autofocus.
Cutting. Please wait.
So there, you heard it that to start the process of translating this grade 1 Braille image, this grade 1 Braille document into speech, Well,
On contracted Braille document,
There.
Armadura University Overlators on page 2 of 2 when away from your doorstep departed. My sons in the flight of the years, still conscious and firm and cold-hearted, we will hail thee with songs and with cheers a thee.
so there it tells us the translation of this Braille document. The detected words, and n is the total number of words in the document. So here's a sample of our testing results. We have used a Microsoft word count functionality to be able to count the number of words. So you see there, we highlighted the words with yellow highlights as an error. It is counted as an error, and in the left column, then at the middle column, you can see here the contents of the original document. And based on our testing procedure, we can have our test results or the word accuracy rate. So for the 10 data sets that we have tested using the same test procedures, we have achieved at least 87.61% word accuracy percentage for the performance of our system.
We, the researchers, have successfully created a new method in building and designing an unconstructed Braille document reading system. And this has been presented by integrating a Python code into the system. So our prototype has also been able to produce an audio document or translation for the given Braille document. And this was achieved using eSpeak by Raspberry Pi and using the library of Python text-to-speech. And undergoing the results for our statistical treatment, the prototype was able to achieve an 87.61% word accuracy rate.
To our future readers or people who could continue our study, our message is we recommend to take a deeper dive on learning Braille reading. It is a must to study rules of Braille reading and other universally used or standardized Braille code so that the device that can be produced is more helpful to interested Braille readers. And we also recommend to add an additional layer of error detection and correction so that it can improve the accuracy of Braille reading. That's all, everyone, and thank you for listening.